Today we're going to look at linear transformations of data. You use these in situations, for instance, where you want to change units. Maybe your data are measured in inches, you want to change the units to centimeters or something like that, or change feet to meters, whatever. In situations like that, you can usually use just a conversion factor. Just multiply all of your data values by that conversion factor and you get your data in the new units. In other situations, you might want to add a particular value, a constant, to all of your data values to just make it more easy to work with. So here's an example of what we can do. I put some data into a list. It's a contrived data set, 7 observations. You can see the median is 3, the quartiles are 2 and 4, the IQR is 2. And if you look at a box plot of this, it looks like that, symmetric. And we're going to transform these data values by adding a constant to them. Let's say we add 5 to all of these data values. So we're going to add 5, and we're going to store that in another list, list 2. You see what happens here. All the values in the previous list went up by 5. Now the median is 8, which is 5 more than 3. First quartile is 7, which is 5 more than 2. Third quartile is 9, which is 5 more than 4. But the difference between 7 and 9, the IQR, is 2, just as it was before. So what happened here was measures of center got changed. The median went up by the same amount that we added to all the data values, but nothing happened to the spread of this distribution. If you want to see what this looks like as a picture, we can turn another plot on here, and then when we graph, you can see here's the original data set, here's the box plot for the transformed data set. So adding a constant changed the measures of center, but it did not change the measures of spread. So that's the first takeaway from that. Okay, adding a constant to all data values changes measures of center by the same constant, but has no effect on measures of spread. Now let's see what happens if we multiply all of our data values by a constant. So what I'm going to do here is I'm going to take my original list, list 1, and I'm going to multiply it times 2. So I'm going to double all the data values, and we'll see what happens. And I'm going to store that in list 3. And there you go. You can see the new list. The median is 6. The first quartile is 4. The third quartile is 8. You can see that the original median of 3 got doubled when we did this multiplication process. It got doubled to 6. But also, these quartiles got doubled. And as a result of that, the IQR is now 8 minus 4. That's 4, which is twice as much as the old IQR was. So when you multiply all of your data values by a constant, you're not only going to multiply all of your measures of spread, of center rather, by that constant, you're also going to multiply your measures of spread by that constant, with one exception. And that is the variance. Okay, if you multiply all of your data values by a constant, you're going to multiply all of your measures of center and spread, except the variance, by that same constant. The variance is a little bit trickier. When you multiply the variance, when you multiply the data by a constant, the variance is going to get multiplied by the square of the constant. That's something you might have learned about in your geometry class, where you have similar figures, and if the scale of linear measures is, say, 2 to 1, then the scale of area measures would be 4 to 1. So we'll look at a picture of that and see how that looks. This picture shows how this works with the variance. If we have a standard deviation S, the variance is going to be S squared, and the original variance before we transform the data would be the area of this small square right here, S squared. Okay, if we double all of our data values, the new variance is going to be 2S times 2S, and that's going to be 4S squared, the area of the large square. So that's a little geometric illustration of how that works. Going back to our box plots with these data we were looking at, if we turn the third plot on and then draw the graph, see the 3 box plots. Here's the original box plot. Here's the box plot after we added 5 to all the data values, and it has the same spread as the original, and it will have the same shape as well. The third box plot will have the same shape as the other two. It's symmetric, but everything is twice as wide, and that's what multiplying by 2 does to your data values, and it multiplies all of your measures of center and spread by 2, except again that variance, which gets multiplied by the square of whatever constant you multiply your data by.